This conference will now be recorded.
Hello, all. Good morning. Welcome back. Yeah. So we are working on Terraform, right? Still, we have few more concepts to cover. So we'll try to complete today. Okay. So we have few more concepts like Terraform Planout. Okay. Terraform Planout and Terraform Droplets. Okay. Terraform Tainting. Okay. Few concepts are there. Let us try to complete today. So from tomorrow, we'll start GCP, Google Cloud Platform, and also if possible we'll work on project. Okay, so we perform few activities on project. Okay, yeah, one project is completely CI/CD project. Okay, another project is we can use Terraform project or Kubernetes project. Okay, either it can be Terraform or Kubernetes. Fine. Yeah, let us start. Can you see my screen, everyone?
Yes, sir.
Terraform Planout. So these three concepts are a bit theoretical. Okay, so let us discuss about this. First one is Terraform Planner. Okay, so what is Terraform Planner? Okay, so basically when we are working on some activity, any activity, okay, so when we plan this, when we initialize the activity, when we plan that, whatever plan that activity, we can save that plan into somewhere. Okay, in the Terraform Visual Studio Code itself, we can save the plan. Okay, plan out one tab will be created. In that we can save the plan. So for example, I want to create some infrastructure. Okay, so that infrastructure I want to save somewhere. Infrastructure details I want to save somewhere. The plan which I'm going to perform. Okay, so in that case, what we will do, we'll use planout script here. Okay, planout command. So when you perform planout, okay, so one file will be created, which will be the file which will have this plan, whatever plan you are going to perform. Okay, so the plan will be available inside of the file. Okay, so we can give the file, you can specify the file. So in that file, the plan will be saved, right? So I want to make the plan, I want to make that plan out, I want to use the same config for apply, right? So in real time, normally when we plan that plan, we can save and we can reuse whenever we want. Fine. Yeah, let us check that. So I'll show you in the console. Yeah, for example, this is my activity. Okay, so I have this activity. Yeah, whenever I need it, I want to perform this activity. So in this case, what I will do, what I prepared the script, what I planned, okay, that plan I can save in different files. Okay, so whenever I need it, I can use that plan, right? So in this case, what I will do here, so go to CD, is the folder, just a minute. Fine. Now, so I want to save this plan. This is my plan. Actually, I want to create one instance. Okay. So this is my plan. I want to save this plan. So for which I use some commands here. Okay. To save this plan. So now go to this folder. cd ec2 batch 9 something is there, right? Yeah. Now Terraform init Terraform plan. Yeah, this is my plan. One to add. Okay, so whatever I planned, so I want to save this plan in somewhere. Okay, so for which command here is Terraform Planout and file name, whatever file you want to use for this. Okay, so command here is Terraform Planout space out space. Okay, where you want to save this. I want to create one file, and instead of that file I want to save this. File name is config dot Terraform. I want to save this plan out in this file. Okay, I want to save this plan in config.terraform. Enter. Now the plan is one file is created here. See here, config.terraform. One file is created, right? So in this config.terraform, the plan is changed to perform exactly these actions. Run the following command to apply. Okay, so this is the file where you save this. If you want to perform this activity, this is the command. We know this command, right? So now, for example, instead of applying Terraform apply, I can use different command also. Terraform apply file name also. See here. Now, if I apply Terraform apply, the infrastructure will be created, right? So instead of giving that command, I can give other command. Terraform apply config.terraform. I can use it. I'll show you. Terraform apply. Normally we use this command to create infrastructure, right? So instead of using this Terraform apply and config.terraform, you can use. Okay, so enter. So now it is taking from config file instead of directly applying. Okay, now it is creating instance. So the file name, whatever you want to give, you can give. Different names you can use. Okay, your name also you can put, but .terraform should be required. So for example, Devakar.terraform. You can give like that. In that, whatever you plan, that will be available. Right? So this is the way. So we use Planout. Okay. And next one is Terraform Droplets. Okay. So what is Droplet? We'll try to understand. Terraform Droplet. So Droplet is new term, right? So don't confuse. If anyone asks you in the interview, what is a droplet? If anyone asks you, droplet is a VM. Okay, VM. So droplets, where we use this droplets? So we use this droplets in DigitalOcean. DigitalOcean also having one platform. Okay, so DigitalOcean we can call it as droplet. VM is, we can call it as droplet. So why we are discussing this droplet? So most of the companies they are opting DigitalOcean also. Okay, so like AWS, Azure, GCP. So most of the companies DigitalOcean they are taking because DigitalOcean is very cheaper platform to perform, to create infrastructure, to maintain the deployments, to use the storage resources. DigitalOcean is very cheaper. That is why. So in our project also we are opting. We opted this DigitalOcean. Okay. So now if you go and search here in the browser, Terraform Droplet. It's such like this. What it is showing here? DigitalOcean Droplet. DigitalOcean Droplet means this DigitalOcean is a platform. Okay. In this, yeah, this is the syntax. DigitalOcean, if you want to create one VM, see here, this is the syntax. DigitalOcean platform is not there in our test lab, but this is the syntax. Create a new web droplet in the, this is a region, some region. Okay. A resource, DigitalOcean Droplet, right? Images, Ubuntu, name, web-1, region, this is region. Okay. Some Netherlands, something, this region, NYC, different terminology. Okay. Size means T2 micro, T2 large, T2 nano. The same way in DigitalOcean also there are sizes here. S-1 virtual CPU, 1 GB RAM. Okay, so this is the size of the virtual machine. This is the syntax to create droplet. Okay, and also here in droplets we can call it as different terminology, which is like normally, for example, if you want to, so if you want to call storage, droplets are VMs, right? As we discussed, droplets are virtual machines, VMs, right? And the storage we can call it as spaces. Spaces means storage. In DigitalOcean, spaces means storage. And we can call it as Kubernetes, means Kubernetes only. In DigitalOcean, the same name we can call here. Right? So yeah, just for idea, so I'm giving this. This is very important. Okay, so normally most of the project teams they are opting this DigitalOcean droplets. Okay, because costing. So why the project teams are going for multiple platforms? Because of costing. Some services will, for example, AWS. AWS is a bit costlier compared with all other platforms. Okay, so in our project we have 3 platforms along with 4 platforms along with DigitalOcean. So some customers they will ask you to provide cheaper cost. Okay, we have this much of budget, we require this many servers. In that case, we suggest GCP or DigitalOcean. So some customers, premium customers, they will ask, we required very quality servers, very high performance servers, but we have budget, but we suggest better one, better perform servers. We can suggest AWS. Okay. Yeah. That is why. So we have Europe customers. Europe customers, they have very startup companies, small companies. They asked us to provide limited budget. Within the limited budget, they asked to provide some limited servers. Okay, cheaper servers. In that case, we suggest this DigitalOcean droplets. Okay, Yeah, simply. It's very user friendly. You can, yeah, AWS is blueprint of all the platforms. If you are good in AWS, you can handle any platform. Okay. Next one. Next one is one more concept is there, which is tainting. Tainting concept. Okay. So tainting concept to Terraform Graph also there. Okay. So tainting means tainting resource in Terraform. So let us try to understand tainting. Tainting resources in Terraform. So theoretically, we can understand this one, and Terraform Graph also we can understand theoretically. Tainting resource. Okay. So when we talk about tainting and in general, tainting and tainting. For example, we have four-wheeler. Okay. So sometimes what will happen? That four-wheeler vehicle. Okay. Some scratches will be happen. Scratches and some damages will be happen. By the time, normally what we will do, we'll move to showroom and we'll tainting that vehicle, right? Tainting means renovation, reconstruction, right? So the same way here in our Terraform also, we can taint the infrastructure. We can taint the infrastructure means, so while working on some infrastructure, okay, so project team require different things. They want to renovate that. They want to upgrade that. Okay. By the time we use tainting resources. Okay. Let us go and check here in terraform.io. Tainting resources in Terraform. Just type this. See here, command taint Terraform by HashiCorp. So always you go with official site only. You don't go with other sites. So different sites will be there. Devopspool.com. Don't go this. Okay. You can use official site only. Open this. See here, the Terraform taint command informs Terraform that particular object has become degraded or damaged. Okay. So Terraform represents this by making the object as tainted. Okay, in the Terraform state. So in which case Terraform will propose to replace it is in the next plan you create. Means what will happen here? So when you want to upgrade anything, when you want to modify anything, resources. So normally we use taint command. See here, Terraform apply replace. This is not actual command. See here, Terraform taint option address, IP address. Okay, so this is the command. So normally in real time we use, but we don't require much. We don't use much. In our project, we haven't used till now this. Okay, so taint is one of the option to upgrade anything, to modify anything, okay, to renovate anything. We use this normally. Yeah, right. So this is tainting. Next one is Terraform Graph. Terraform Graph, one more concept, right? So these are very small concepts, but we have to understand this. So in interview, normally graph, tainting, they will not ask anything. Droplets, sometimes they will ask, what is droplet? Okay. So when I attend last proxy for one of the previous batch guy, I got this question. What is a droplet? Droplet is nothing but VM. Okay, simply we can give. In digital version, it is a VM. Next one is the Terraform Graph. So what is Terraform Graph? Okay, so Terraform Graph command is used to generate visual expression of either a configuration or execution plan. So Terraform Graph means whatever activity you want to perform, that it will show you visual like flow chart. It will show you like a different flow chart. Okay, so like I'll show you something here. Terraform Graph. See here. So when we want to perform any activity, it will show you in some flow chart like this. Okay. So for example, this is some website. Okay. So this is instance, AWS instance, right? See here, AWS instance test1, test2, test0, 3 instances available. Some plan, this is some plan. So we can see this in graphical way, in flow chart. Okay. When we execute this command, it will show you like this. Okay. So some flow chart, some flow providers, AWS. Okay. So graph means normally dot format, it will show you dot format. In the dot format, it will show you like this. So for example, you want to create one VPC, subnets, routing tables, default gateway, so many things, right? So when we execute this command, so it will show you the graph. Within the graph, it will show you this flow. This is VPC name, subnets, this subnets, under this gateway, under this routing tables, like that. Okay, so it will show you graphical way. So route S3 means DNS, that is the DNS, different concept. Okay, someone asking, Sachin I think asking, route S3 means that is a different service in AWS. So let us check this command, whether this command is executing or not. It will not execute normally in our test lab. We'll test it out. Terraform Graph. So it will not execute basically because we don't have resources, we don't have proper the test lab, right? It will not execute. So here it will not execute because we haven't configured that proper way. There is no proper way. That is why it will not execute. Once we created the script and once we set all these things, then it will be executed. Generating images, right? It will generate images. So in dot format. Graph and dot format kada. Graph paper kada. So graph paper is dot format. In that it will show you like this. Painting kuda మనకి రావట్లేదు టెస్ట్ ల్యాబ్ లో. So these are the things and few more things. So one more lab session will work in project. Okay, so one more concept which is dynamic blocks is there that we can work on project session. We can work on that. So these are the concepts as per the content we cover. Okay, so next one is one more small concept is there. We can discuss that we can complete. So cross account resources. cross-account attributes. Terraform cross-account attributes. This is the last concept in this. Terraform cross-account attributes. So what is this? Okay. So cross-account attributes means VPC pairing. VPC pairing. Using Terraform, we can create multiple resources. Okay. Under cross platforms. For example, we have two VPCs. One VPC is here, which is Europe VPC. In Europe region, we have VPC 1, and also we have another VPC which is in APACHE region. Right. So these are the different regions, different VPCs. Okay. So now what we are doing here, in this first VPC, we have different subnets. Subnet 1, subnet 2. So here also different subnets. We have subnet 1, subnet 2. Right. So now what I will do here. So in the APACHE region, I want to create normally the resources. Okay. So at a time, in two regions, two different regions, we can create same resources. Okay. Whatever resources we are creating here, the same resources we can create in Europe also by using cross-account attributes. So normally, region-wise, we perform this activity. So when we enable this cross-account attributes, okay, we can create multiple resources in multiple regions, different regions. This is nothing but VPC pairing. First, we have to enable this pairing, VPC pairing. Pairing means connectivity, right? So once we enable this pairing, what will happen? So this subnet is different subnet. This subnet is different subnet. Okay. Region-wise subnet will be changed. IP addressing will be changed, right? So once we enable this cross-account attributes, so irrespective of subnets, irrespective of regions, we can perform Terraform infrastructure activity. Okay, we can create infrastructure in different regions using this cross-account attributes. Okay, so yeah, theoretically we can understand this. Practically we cannot work on this because we don't have any peering to be enabled. Fine. So these are the concepts. Okay, next tomorrow we'll start GCP. Still we have time, but when I start GCP, it will take 1 hour. First session it will take 1 hour. Okay, what is GCP? What are the regions? What are the availability zones in GCP? What are the differences between AWS and GCP? What are the costing? What are the security layers in GCP? All these things will cover tomorrow. So GCP will take 5 sessions. Okay, this weekend also we have session. Saturday also we have session. Same timing, 8 to 9. Okay, so we'll complete GCP in 5 days. Within 5 days we can complete. After that we can work on Azure. After that we start working on projects. We'll have 2 live projects. In that first one is CI/CD project. Second one is either it can be Terraform project or Kubernetes project. We can perform. Okay, so mostly we complete this month end. So before projects we'll have some general sessions. What is ticketing tool? what type of ticketing tools we have, ServiceNow, Remedy tool, Jira tool, right? And what is, how to fill the timesheets, what is the leave management system, what is ITL process, all these things we cover in general sessions. Also, I explain day-to-day activities. Day-to-day activities also, I take one session. Fine? Providers అంటే మనకి ఇక్కడ ఉంది కదండి, మన స్క్రిప్ట్ లోనే కవర్ అయిపోయింది. ప్రొవైడర్స్ అంటే సో ఏ ప్రొవైడర్ అయితే మనం యూస్ చేస్తామో ఆ ప్రొవైడర్ గురించి మనం మాట్లాడుతున్నాం. అంటే స్క్రిప్ట్ లోనే కవర్ అయింది మనకి, రైట్?
డీబగ్గింగ్ ఇన్ టెరాఫార్మ్ అంటే
ఏంటండి? డీబగ్గింగ్ మనం చూద్దామండి, ఇది ప్రాజెక్ట్ ఒకటి చేద్దాం అనుకుంటాం కదా. సో ఏదైతే అంటే మనకి ఇంపార్టెంట్ అన్ని కవర్ చేస్తాం, లేదా ఒకటి రెండు అంటే అవి డీబగ్. మనం ప్రాజెక్ట్ ఒకటి చేద్దాం, టెరాఫార్మ్ ప్రాజెక్ట్ ఒకటి ప్లానింగ్ ఉంది. సో దాంట్లో ఒకవేళ కానీ చిన్న చిన్నవి అంటే అన్ని అసలు మనకి మీకు మోస్ట్ ఆఫ్ దీన్ని కవర్ అయింది. సో ప్రొవైడర్స్ ఇవన్నీ కూడా మీకు ఒక డాక్యుమెంట్ ప్రొవైడ్ చేస్తాను ఈరోజు. I'll send you one document. In that you will have all the information. Okay. So theoretically ఎక్కువ ఉంది వాళ్ళకి సబ్జెక్ట్. సో మనకి ఏంటంటే రీయూజబిలిటీ ఎక్కువ. సో యూజ్ చేస్తా ఉంటాం స్క్రిప్ట్ మళ్ళీ, రైట్? థియరిటికల్ గా యూ నీడ్ టు అండర్స్టాండ్ most of the things. Okay. I'll provide you one very good document I have. So I'll provide you that. You can go through theoretically. So Terraform ఇంటర్వ్యూ క్లియర్ చేయడం చాలా ఈజీ అండి Terraform పైన. ఎందుకంటే మీరు ఒకసారి ఇంటర్వ్యూ క్వశ్చన్స్ ప్రొవైడ్ చేస్తున్నాను, అది గో త్రూ అవ్వండి. సో జీసీపీ విత్ టెరాఫార్మ్ అంటే సో ఇది హార్ట్ అనమాట. ప్రజెంట్ జీసీపీ ఉండి టెరాఫార్మ్ ఉంటే ఈజీగా క్రాక్ అయిపోతుంది. కాన్ఫిగరేషన్ ఫైల్స్ అంటే అది ఏం లేదు, సింపుల్ థింగ్. కాన్ఫిగరేషన్ ఫైల్స్ అంటే ఏముంటుంది? కాన్ఫిగరేషన్ మేనేజ్మెంట్ అంటే ఏంటి? మన ఇన్ఫ్రాస్ట్రక్చర్ కాన్ఫిగరేషన్. ఓకే. సో ఇవన్నీ థియరిటికల్ సబ్జెక్ట్స్ అండి. వ్యాలిడేటింగ్ టెరాఫార్మ్ కాన్ఫిగరేషన్ ఫైల్స్. యా. సో మనం ఏంటంటే సో నార్మల్ గా ఏదైనా యాక్టివిటీ చేసినప్పుడు ఫస్ట్ వ్యాలిడేషన్ అనేది ఇంపార్టెంట్. సో మనం ఫర్ ఎగ్జాంపుల్ మీరు గిటాబ్ నుంచి కోడ్ చేస్తున్నారు, Jenkins through deploy చేస్తాకే you are trying to pick the code from GitHub to Jenkins. ఓకే. సో అక్కడ మనకి కోడ్ అనేది వ్యాలిడేషన్ జరుగుతూ ఉంటుంది మధ్యలో. ఎవరు చేస్తారు? అక్కడ సోలార్ కోడ్ రివ్యూ టూల్ ఉంటుంది, సోలార్ ఉంటుంది. సో ఇక్కడ ఎవరు చేస్తారు? టెరాఫార్మ్ వ్యాలిడేట్ చేస్తారు. జస్ట్ వ్యాలిడేషన్ అండి, అది ఇంటర్నల్ ప్రాసెస్. వ్యాలిడేషన్ అంటే ఏంటంటే కోడ్ స్టాండర్డ్స్ అంతే. ఓకే. సో అది మీకు డాక్యుమెంట్ ఇస్తాను, సార్ చూడండి, అది సింపుల్ వన్. ఓకే.
Sir, I have a doubt.
Yes.
We can use in one file itself for creation of instances, VPCs, or S3 buckets, right? So when we use that, when we initialize that, everything gets created, right? So if we want to destroy only one particular VPC from that file, how can we do it?
One particular activity you want to perform, right?
No, in the same file, I want to create many things like instances, VPCs, buckets, everything I want to create. But if I want to delete only one thing from that file, then how can we do that one? Because if we use destroy, then everything will get removed, right?
Okay, fine. So yesterday we discussed something, right? Something like what we discussed yesterday. So in that I cover something, right? For example, we have VPC, EC2, subnets, S3 buckets in the same script. You want to destroy only one vector resource. That is your question, right?
Yeah.
So in that case, we have to create some variables here. So yesterday we discussed, right, variables. In that it will be covered. Okay. So I'll give you some document. You can work on that. You can try multiple TF scripts. You can use multiple TF scripts. So we have nearly 50 TF scripts in that document. 50 to 55 scripts are there. You can try different way so that you will understand. Okay. So I'll provide you the document. You can go through the document so that you will get it.
Okay.
Fine. So you can stop here, you can stop here for today. So tomorrow we'll start Terraform. So Google Cloud. Okay. You can practice Terraform. I'll give you a document. So if you face any challenges, then we'll discuss again that. Okay. Fine. We stop here for today. Thank you all.